We are moving on from Unit 8 to Unit 9. So let's look at our journal, our Teach Tracker. So we are getting close to being finished with our skills for this year. Unit 5 is what we have learned. So highlight the 5 skills that are in Unit 5. This is all about exponential functions. We are finished with that. And we also have done in category 1A 11B. So look at A11B. So that's that one up here, reporting category 1, and then all of reporting category 5. And we did not have an exam for that, but we are using the EOC review as the exam. The one that I passed out on earlier this week. So let's look at our Unit 9 divider. That is what we are about to start. So these are all the skills for Unit 9. So this is the quadratic function. Let's look at our vocab. Let's not glue it in just yet. Let's just look at the vocab. Quadratic function, a function in which the greatest power of the variable is x. When we had exponential, we had that the variable was an exponent. Now with quadratic, the exponent is 2. The parent function of quadratic is y equals x squared. So I want you to look at this in your calculator. So open your calculator, clear out what's in there, and we're going to look at what a quadratic function is. It has a silly name, and then parabola is the next vocabulary word. So there's lots of new vocab for this. So y equals, the parent function is the most basic. When we have linear, our parent function is y equals x. That's just a line that goes through the origin, has a positive slope. So the parent function for a quadratic is y equals x squared. So put in x squared. So let's look at what the graph looks like. What does it look like? Does it look like a V or a U?
U.
A U. Why? Why is it a U instead of a V?
Well, V's like having a curve.
Yeah, that curve. There is actually another function that you'll learn in Algebra 2 that is a V function. It makes a V. But this one is definitely a U because it has that curve to it. With exponential, we had a curve to it as well because of the exponents. So anytime you have an exponent other than 1, your graph is going to have some kind of curve to it. So this is the most basic quadratic function. It goes through the origin, and it's positive. It's going in a positive direction, left and right. This is called a parabola. So parabola is the next vocab word. The shape of a quadratic function. So why don't we draw a picture of it? That is a parabola. Parent function, I do want to put on here, goes through the origin. The vertex. Do y'all remember back in elementary school, we had these 3D figures and we were asked for vertex, edge, and faces? Do y'all remember that? Man,
Yes.
it's been a while. My kids are working on that right now in elementary. So that's what made me think of it. So what was considered a vertex of a 3D figure? A point, right. A point. How do we describe that? Point what? So like this 3D shape. So if I have this, where would a vertex be? So can I say this is a point?
No.
Where would the point be?
Yes.
Well, this is an edge. Yeah, a corner. Yeah. It's where it changes direction. So this edge is going like this, and then you stop right here and it changes direction. So where it changes direction is a vertex. So same thing for quadratic. The point where the parabola changes direction, we call it H and K. We use the letters to represent that. Also call it a maximum or minimum point. So if we look here, where does it change direction? At the very bottom, yeah. So it's the parabola is going down, 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 and then it finds a minimum point and then goes up, 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 up. What if we had, I'm going to have you change this, clear it, and put negative x squared. What do you think that's going to do?
Make it go down.
Make it go downward.
Like
Yeah,
an
like an N. Mm-hmm. So put in negative x squared. Let's hit graph. It also goes through the origin, but it's going downward. So if I draw one like that, it's kind of like a mountain. So this is called the peak of the mountain. So it's also called your maximum point. So this is also a vertex. So no matter which way the parabola is facing, you have a vertex, and that's the point where it changes direction. Axis of symmetry is the next one. What does symmetry mean?
Mirrors.
Same on both sides, mirrored. That's right. So if I have this parabola right here, I need to be able to draw a vertical line that cuts it directly in half. So draw a little dotted line down the middle of it. This is going to be called your axis of symmetry. It's going to be written as an equation, x equals some number. Because remember, whenever we have vertical lines, that's an undefined slope. So it wouldn't say y equals a number, it'd say x equals a number, wherever that vertex is. And we have maximum and minimum. So right here, what would this be called? A max, because it's kind of like your peak. What would this be called? A minimum. Now we have 0 of a function, the x value of the x-intercept, solution to a function, the x value of the x-intercept, x-intercept, point where the function crosses the x-axis. These all represent the exact same thing. There's actually one more word that I forgot to put on here, and it's roots. And roots are x-intercepts. So these 4 things, 1, 2, 3, 4, they all represent the same thing, which is x-intercept. So I'm just going to put over here same. They have different names. And they all represent the x-intercept. And then we've learned about domain and range. Domain is all possible x's, and range is all possible y values. We saw that with linear, we saw it with exponential, now we're going to see it with quadratic. Okay, go ahead and glue this in and then open up your new digital interactive notebook that I put on Google Classroom. So let's look at your Unit 9 quadratic functions, DI and B. Go ahead and open that up. We're done with exponential functions. You need to make sure that you have all the slides completed, pictures uploaded, and turned in today. Now we're on quadratic functions. So go ahead and open that up. It has a maroon cover. Okay, the first few slides are the same. Just a reminder, make sure that anytime you miss class, you're not off the hook for that assignment. You need to make sure to watch the video that's on Google Classroom and complete the notes and assignments. That's your responsibility. Okay, EOC review chart. We are dealing with quadratic functions, so we can zoom in on this. Let me see if I need it. The bottom formulas, it says quadratic equations. We have 1, 2, 3, 4 formulas in our formula chart for quadratic functions. This is also in your journal, so you can look at these formulas. They look a little bit more advanced than our other ones, right?
A lot.
We got this square root, a plus and minus. We have squared in here. So we'll be talking about each one of these. Easiest one is x equals negative b over 2a. This is your axis of symmetry. So we'll talk about where a and b come from, and that's from the formula that's standard form. Ax squared plus bx plus c. That's the standard form, and we use that for all the rest of these formulas. Well, except for the vertex form. Okay, let's keep on going. Just some reminders there. Let's look at slide 5. We have f of x equals ax squared plus bx plus c. Now what I want you to do is I want you to drag and drop each one of these vocabulary words to where they belong. Here on this graph and also in the notes part. So what is this dotted line that goes down the middle of a parabola? Axis of symmetry. So drag that over and then flip it around. Use that little pivot tool to flip it around. Okay, zeros. What are zeros? Look back at your notes that are on your unit divider. There were those 4 terms that were the exact same. Do you remember what they were?
Roots.
Roots, which is also called x-intercept. All of these mean the same exact thing, which is x-intercept, x-intercept, x-intercept. Crosses the x-axis. They all mean the same thing. So 0 will go here. See that point right there on that parabola? It touches the x-axis right there. So that's a root or a 0. So I'm going to pull these over. It's also called a solution. It's also called a x-intercept. So we have 4 vocabulary words that represent the same thing. So I'm going to copy these over here too. They all represent the same thing. X-intercept. Okay, so we've done axis of symmetry, roots, zeros. Y-intercept. Where would that be located? In relation to the axis of symmetry, which way do we go on this parabola for the y-intercept? It's right here to the left of it. So drag the y-intercept over. This parabola is going down, 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 up, up, up. So it is an upward parabola. So our point right here, what is that called? Where it changes direction. Max and min, yeah. It also has another name, vertex. Okay, the next thing, what is this pointing to, this little arrow pointing to? Look at all of our possible vocabulary words. What is this arrow pointing to? Which vocab have I not used yet? The what? It's the shape of the graph. Do y'all know how to say the shape of the graph, what it's called? Parabola. Y'all say it. Parabola. Okay. Parabola. Okay, so we have everything labeled. Oh, domain. What are the domain? What is the domain? So we just need to put on here all possible x values. You're going to have to extend the box so that it doesn't carry over to the next line. And then what is the range? All possible y values. Okay, let's look at this. It says quadratic functions will always have a variable squared in the equation and will create a parabola as its graph. The domain of the parabola will always be all real numbers, and the range will always be greater than the minimum or less than the maximum values, unless there are other constraints on the function. So let's look at our first definition. It says point where the function crosses the y-axis or have an x value of 0. What is the point where the function crosses the y-axis? What is that called? Any point or anywhere where the function crosses one of the axes is called either an x-intercept or y-intercept. So this is where it's crossing the y-axis, so it's going to be your y-intercept. So come over here, grab y-intercept, and drag it over. And so there's an algebraic application that says, evaluate the function when x equals 0. Since f of 0 equals c, the y-intercept is 0c. And the next one, point where the function crosses the x-axis or have a y value of 0. What is that called? Point where the function crosses the x-axis. X-intercept, yeah. There could be more than one x-intercept. There could be none, or there could be 2. 1, 0, or 2. There are other names for x-intercept, though. Let's see, do we have any others that we could drag over there? Roots and zeros. And then solution is the next one. Values of x that make f of x equals 0. So we'll put solution down here. So all 4 of those mean the same thing. And this is that, it looks kind of like an ugly formula, doesn't it? This is called the quadratic formula. Set the function equal to 0. In general, the zeros can be found using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There is a song that goes with this that you will learn, and you won't be able to get it out of your head. Okay, the next one is the vertical line through the center of the graph. What is the vertical line through the center of the graph? What is that called?
Axis symmetry.
Axis of symmetry. Very good. So let's pull that over here. The formula for the axis of symmetry is x equals negative b over 2a. That's a simpler formula. I think we can do that one without much help. The next one, the highest or lowest point on the graph of a quadratic function. What's that called?
Maximum and minimum.
Maximum or minimum. Actually, it's called the vertex because it's the point. In order to be a point, it'll be an x and y. But then the next one says just the y coordinate of the vertex. That's your maximum or minimum. So the vertex is written as a coordinate. Maximum or minimum is just written as a y value. So it's your highest or lowest y value is what a maximum or minimum is. Okay, let's go on to slide 6. Characteristics of quadratics notes. Types of parabolas. Is there any? Yeah, there's some drag and drop. One thing that we do need to add on here, though, go ahead and make a text box. And we are going to add that standard form on here. So we're going to write y equals ax. We need to do a squared. So control less than, nope, control greater than, squared. And do control greater than again, plus bx plus c. I'm going to make mine bigger, and I'm also going to shade it with yellow. This is called the standard form of a quadratic function. So the first function that we have is f of x equals x squared plus 2x minus 5. If a is, so what's the number in front of x squared? What is the a value? Here. If there's nothing in front of it, what do we say is actually right here? A 1. So if a is, we're going to be more general about it and just say is positive. So grab the positive text box. If a is positive, the parabola opens what way?
Upward.
Upward, yeah. When the parabola opens upward, it has a, is this going to have a minimum or maximum?
Maximum.
But these arrow means it goes on and on forever,
Oh.
right?
Mhm.
So then the only restriction we have is a minimum. So right here is minimum. Whenever it opens upward, we have a minimum value. So it starts at this number and then goes on and on forever to positive infinity. So this would be a minimum. Think of the parabola smiling and having a minimum amount of problems. So if it opens upward, it has a minimum. So then the next one, look at this one, how this one is. Negative x squared plus 2x. So the number out front, if it's positive, it opens upward. So if it's negative, how is it going to open? Downward. So if A is, need to grab the negative. The parabola opens downward. Pull all these down. So it opens downward. When the parabola opens downward, it has a maximum. Because it has a highest point, it has a peak. So anytime it has a peak, think about peaks and valleys. This would be considered a peak, so it would have a maximum. The peak is your maximum, and then the other one, this is a valley, so it's a minimum. Think of the parabola frowning and having a maximum amount of problems. Okay, that is all we're going to do today. We'll finish these slides tomorrow.